Hi, I'm Jack Simons at the University of Utah. This is a picture of me in the mountains in Utah. And I'm going to be introducing you to this second edition of my textbook on Introduction to Theoretical Chemistry. In this first session, I want to introduce you first to some links that I think you'll find useful. First of all, there's a link to my personal web page at the University of Utah. And this web page contains links to lots of other sites, including other ones I'm about to mention. And then there's the link to my what I call theory page. Several years ago, I created a website that describes theoretical chemistry as a discipline within chemistry and provides many educational links as well as links to practicing theoretical chemists throughout the world. Third is the link to the Telluride Schools on Theoretical Chemistry. This is a series of summer schools that I founded in 2009 that will be held every 2 years and will deal with the subjects of electronic structure theory, statistical mechanics, and reaction dynamics, and is appropriate to PhD students and postdoctoral students studying theoretical chemistry. So I encourage you to look at that site. And then finally, there's a link to the second edition of this textbook, Introduction to Theoretical Chemistry, where you can download for free all the PDF versions of all the chapters of this textbook. So I encourage you to go to that link to do the downloading. Now, the first thing I wanted to mention is just what is theoretical chemistry, and that's one of the things in the textbook I try to explain pretty clearly, because most students of chemistry take, as undergraduate students, they take freshman chemistry, organic chemistry, inorganic chemistry, analytical, biological, physical, but they never take a subject called theoretical chemistry. So I try to make it clear that theoretical chemistry is a discipline within the field of chemistry that is an important connector between the microscopic world of the molecules and the macroscopic world of the laboratory. The other thing I wanted to mention briefly here is I try to explain in this book that you can use the book in at least two different ways. One is the textbook could be used as a text for undergraduate level physical chemistry, the quantum mechanics part of a physical chemistry class, by studying chapters 1 through 4 as well as chapter 5. Alternatively, the book can be used as a first-year graduate level text by using chapters 5 and chapters 6, 7, and 8, where I do electronic structure theory, statistical mechanics, and reaction dynamics. So the book is versatile that you can use it in different manners. Now, also, I just wanted to mention some other sources of information that I hope you'll find useful. First of all is this theory page link that I mentioned earlier to the web page that I created several years ago. And then there's several textbooks that I mentioned. I think the two that I'd like to highlight here are the Modern or Molecular Electronic Structure Theory by Tryggve Helgaker, Paul Jørgensen, and Jeppe Olsen. It's a very cutting-edge book on electronic structure theory. And then there's the book by David Chandler, Introduction to Modern Statistical Mechanics. That's a book that's very widely used in a lot of American universities, and it's probably the most, let's say, up-to-date and useful textbook at a graduate level. Of course, there's other classics in here. There's Eyring, Walter, and Kimball, and Pauling and Wilson's books on quantum mechanics, as well as Szabo and Oslin's excellent book on modern quantum chemistry, and Dick Zayer's book on angular momentum. But all of these resources are quite valuable. Now, in the other lectures that I'll be presenting here, I go through in a little bit of detail each of the chapters in the book, and I just wanted to mention these chapters here. Chapter 1 deals with the basics of quantum mechanics. Chapter 2 deals with various model problems that we use, rigid rotor, harmonic oscillator, and so forth. Chapter 3, electronic energy surfaces and what you do with them. Chapter 4, some tools like point group symmetry, perturbation theory, variational method, and so forth. And then chapter 5 provides an overview of how theoretical chemistry interfaces with experimental chemistry to probe molecular behaviors. And then in the more advanced chapters, 6, 7, and 8, I deal with electronic structure theory, statistical mechanics, and chemical dynamics. And as I said, I'll be overviewing all these chapters in the next series of lectures here. And finally, I want to mention that there are problems and solutions that you can find online and download that deal with the material covered in this textbook.